Hello, everyone. Welcome to the Safer Alternatives for Solvent Applications webinar. My name is Jean Waters. I'm a longtime pollution prevention professional and currently project manager with Pprc, the host of this webinar. I'm pleased to welcome you all to this webinar and to provide a little background before our feature presentation from Dr. Katie Wolfe. We have a varied audience today, which is great. And the audience includes representatives from industry, EPA, state and local regulatory authorities, universities, and nonprofits. We hope you will all learn something from Dr. Wolfe, and we're sure you will. Most of the research presented here today is the result of collaboration among EPA, state, local environmental agencies, businesses, and nonprofits. I wanted to give just a brief background on Pprc. We're a nonprofit organization based in Seattle, Washington, founded in 1991 to provide pollution prevention information and technical assistance training to a variety of small businesses, local communities, and industrial facilities. Pprc's services come in the form of research, site assessments, face-to-face and virtual trainings, and general information dissemination. And I wanted to point out that we do have a rapid response feature that you can ask a direct question and we will do the research, provide you an unbiased, well-researched response. So if you have a specific question that you need some help with, please do visit the rapid response feature on Pprc and ask your question. Also, a little bit of housekeeping. Please use the question box on the GoToWebinar panel to ask questions. We'll have time for questions and answers at the end of the webinar. Also, we have a very short survey that will launch immediately after the webinar. We would really appreciate it very much if you would take a moment to answer those questions. Your answers will help us put together future educational opportunities. Also, this webinar is being recorded and will be available on the pprc.org YouTube channel. And we will send the link out to you after we get it recorded and posted. The first step in behavior change is awareness. The demonstration projects presented here began with awareness. Industrial solvents were being used ubiquitously, and they contribute to health risks for employees and the community. Volatile organic compounds contribute to ground level ozone, which is a health hazard, and hazardous air pollutants included in many of these solvents are a health hazard. The environmental community is aware of these risks. The second step in behavior change is desire. There was the desire on the part of the regulatory agencies to reduce the risk and the pollution associated with these solvents. And as you all know, there's also desire among industry and among all of you to reduce these risks. The third step in behavior change is knowledge, and this is where Dr. Wolfe's projects are critical. Knowledge was needed in order to know if there are safer alternatives that are effective for their intended use. What process changes may be required to allow the use of safer solvents? Are there other changes that can or should be made? And what are the costs of making the change? My economist friend, Dr. Chris Decker, says that cost is a necessary but not sufficient reason for change, meaning that saving money alone is not enough to get people to change. On the other hand, if people don't want to change, cost can be a good excuse not to change. Between 2004 and 2017, EPA Region 9 awarded P2 funding to state programs, the Institute for Research and Technical Assistance, IRTA, which is Dr. Wolfe's nonprofit, and other partners for numerous projects demonstrating safer solvents to toxic and VOC solvents. The projects address solvent applications and cleaning uses in a wide array of sectors, including alternative compliance for open-top vapor degreasers and for enclosed and conveyorized vapor degreasers under the prohibition of TCE. Alternatives to halogenated solvents and high VOC solvents used at room temperature. Alternatives to methylene chloride paint strippers. Evaluation of NMP as a paint stripping alternative to DCM. Dry cleaning alternatives to TCE in textile spot cleaning. Alternatives to aerosols used in auto repair facilities. Safer cleanup solvent alternatives in the auto body industry. Printing equipment cleaning, and many more that we can't cover today due to time. It was important that safer alternatives existed and that they could be used by the regulated community. These projects that Katie did demonstrated safer alternatives and avoided regrettable results. They paved the way for regulations that provided awareness and desire for industry to make changes. The desire for change and improved health aspects led to regulations by state and local agencies. The regulations and chemical phase-outs resulted in more than 100 tons per day of emissions reduced. Pollution prevention reduces the amount of pollution generated, and by definition, this requires change. Whether you are an industry that wants to make the changes, a regulatory agency that finds the need to regulate solvents, a university program that provides education and training, or a nonprofit working with industry that is voluntarily making improvements, the knowledge that you gain from understanding the processes used and the understanding of Dr. Wolfe's demonstrations projects will provide you the ability to help implement these changes and help industry implement these changes. We also hope that your involvement with these industries will reinforce the value of these changes for the industries. The industries can save money, have healthier workforce, and be in a safer community and prevent pollution by implementing these changes. And now it is my pleasure to introduce Dr. Katie Wolfe. Dr. Katie Wolfe is a consultant on solvent alternatives working with the Pacific Northwest Pollution Prevention Resource Center, Pprc, our sponsor. Katie was previously the director of the Institute for Research and Technical Assistance, IRTA, a nonprofit organization established in 1989. IRTA's work involved finding safer, low VOC, low toxicity alternatives. IRTA also performed emerging and advanced technology demonstrations that reduce or eliminate the use of hazardous substances. IRTA's work focused heavily on solvent alternatives in cleaning, dry cleaning, electronics, paint stripping, coatings, lubricants, paint thinners, and adhesives. She really has done a lot of work here, folks. Dr. Wolfe spent 14 years at the RAND Corporation, where she performed research on alternatives to ozone-depleting substances and chlorinated solvents. Dr. Wolfe has authored more than 200 publications and has a PhD in chemical physics. Today, she will review a few of the safer alternatives for solvent application demonstration projects that she has conducted. Take it away, Katie.
Thank you, Jean. Good morning or good afternoon, everyone, depending on where you're located. And as Jean mentioned, I'm going to talk to you today about safer alternatives for solvent applications. As many of you may know, there are numerous different and diverse solvent applications. The applications I'm going to focus on today are most of those that either have significant solvent use or are used by many different companies. These selected applications are also those that are covered under the industries defined in the EPA Pollution Prevention National Emphasis Areas, or NEAs. There are, of course, many other applications than those I'll be discussing today, and I'll list some of those later. This slide lists the NEAs for reference. I'm not going to talk about any solvent applications covered by the Food and Beverage NEA, but I will talk about solvent applications covered by the other NEAs. This slide lists the solvent applications I'm going to focus on, and it also specifies the NEAs and the types of companies where solvents are used in these applications. As you can see from the slide, there are a number of applications where I indicate the chemicals industry is involved. In this case, it's because formulators blend solvents and provide them to the users. In the balance of the presentation, I'm not going to discuss the applications in terms of the chemical industry NEA today. I'm only going to discuss the applications in terms of the users of the products. In the future, however, there could be webinars on solvent applications covered under the chemical industry NEA to discuss how best to reformulate the products that make them safer if people are interested in that aspect. There are obviously many different types of operations where solvents are used, and I'll only be able to cover the major ones, as I mentioned already. So the approach that I'm going to use is laid out here on this slide. For each application, I'll touch on the process. Then I'll talk about the solvents that are used in the process and the safer alternatives. That is the low VOC, low toxicity alternatives that can be used in their place. Later in the webinar at the end, as Jean mentioned, in the survey, you can indicate applications you would like to know more about. And there could be webinars that address these in more detail at a future time. The first application I'll cover is vapor degreasing, and there are thousands of companies that use the vapor degreasing process. It's designed to clean contaminants of all kinds and remove them from parts. Large and small companies manufacturing or processing metal parts or assemblies, aerospace contractors, and many job shops have used vapor degreasing for years. The reason vapor degreasing is so widely employed is that it's extremely effective in removing contaminants of all kinds. And it's also very convenient since the parts come out of the process clean and dry, and they're ready to go on to the next processing step. So how does vapor degreasing work? Well, I'm showing a really simple schematic of a vapor degreaser on this slide. It has a heater, it's made of stainless steel, and it has a heater in the bottom and a set of cooling coils around the top. You put liquid solvent into the degreaser and you heat it to its boiling point. This creates a vapor zone above the liquid zone. Now those vapors of solvent would tend to exit out of the top of the vapor degreaser were it not for the set of cooling coils on the top, and they act to condense the solvent back into the vapor zone. The parts are generally lowered into the vapor zone in either on a basket or on fixtures of various kinds. And when the parts are put into the vapor zone, they encounter the warm solvent, and that condenses on the colder part and carries the contaminants on them into the liquid below. So if you always clean in the vapor zone, you'll always be cleaning with clean solvent. Now, most degreasers are more complex than the simple schematic that I showed on the previous slide. And nearly all vapor degreasers have a wand that you can use to spray the part with liquid solvent in the vapor zone. Or some degreasers have immersion baths with certain different types of agitation in them. And you can immerse the parts in those baths for better cleaning. Now, the last point on this slide is really important. The solvents used in open-top vapor degreasers must not have a flash point. If you heat a solvent with a flash point to its boiling point, it'll reach the flash point first. And in an open-top vapor degreaser, for example, there is, of course, oxygen present. And if there's also a source of ignition present, you could blow up or ignite the solvent in the vapor degreaser. So it's very dangerous. With that in mind, the solvents most commonly used in vapor degreasing are those that have no flash point. And these are generally the halogenated solvents, trichloroethylene or TCE, perchloroethylene or PERC, methylene chloride or MC, and N-propylbromide or NPB. And as most of you probably know, these 4 solvents are all carcinogens, and they pose other health and environmental effects as well. All 4 of these solvents are also on the list of the first 10 priority chemicals that EPA is currently looking to regulate under the Toxic Substances Control Act amendments. This slide shows some of the different types of vapor degreasers. This first one up on the top left, it's a large enclosed system that holds 130 gallons of solvent. And the one over to the right shows a worker cleaning parts in a small open-top degreaser. The one on the bottom shows another large open-top degreaser. It holds 110 gallons in this case, and it's dropped into the floor of a facility. Now, taking into account the technical feasibility, various cost and health and environmental concerns, the most viable alternative and the one most appropriate for the vast majority of vapor degreasing operations that are performed today is water-based cleaners. And other safe alternatives may apply in certain selected cases. These would include soy-based cleaners, for example. They're very effective in removing hard-to-remove contaminants like pitch and wax that are used to polish optical components. Some companies may be able to use a burn-off oven to decompose the oils on their parts. Companies assembling printed circuit boards could convert to a no-clean flux, and that would make it unnecessary to clean those parts at all. Finally, some companies that bring in heavily contaminated parts from the field for rework that they're going to refurbish, they might rely on blasting media of various kinds to clean the parts. Now, this slide shows pictures of some of the different types of water cleaning systems. Water cleaning relies much more strongly on physical agitation than does solvent cleaning, and you definitely need to pick the right system for cleaning your parts. If you pick the wrong one, it won't be effective. And the top one on the left shows a conveyorized high-pressure spray system. It includes a wash section, a rinse section, and a dry section. The one to its right on the top shows a spray cabinet where the parts are placed on a turntable. You can see the turntable in the picture. It also has a spray bar that can be raised and lowered depending on the size of the parts. And these spray cabinets can be a wash-only system for gross cleaning, or they can include a rinse and dry. The one on the left on the bottom shows a very high-tech precision cleaning ultrasonic system with a wash, a rinse, and a dry. And the last one on the bottom to its right shows an immersion agitation system. This system has 3 baths, a wash, a rinse, and a dry. And as you see from the picture, it also has an automated handling system, which is used to move the baskets from one chamber to the next. And this slide shows 2 additional water cleaning systems. The top one is a large ultrasonic system that could be used in a plating shop for removing polishing compounds. And in fact, it is used for that purpose. We worked with a company in Los Angeles, and this is the system they ended up buying. The bottom one on this slide, it's a conveyorized spray system, which can be used for cleaning electronic components like printed circuit boards. The next application I'll talk about is cold cleaning. Auto repair facilities and industrial facilities with machine shops rely on cold cleaning to remove contaminants like oils and greases from parts. The solvents in this case are used unheated in batch-loaded cold cleaners or parts cleaners. And I'm sure most of you have seen the safety clean parts cleaners in shops. Some operations might rely on halogenated solvents like trichloroethylene in this category, but most cold cleaning operations are performed with non-halogenated solvents, things like mineral spirits or MEK that are classified as VOCs. And these solvents have toxicity problems. The major alternatives in cold cleaning are water-based cleaners, once again, as was true for vapor degreasing. The South Coast Air Quality Management District in Southern California is responsible for regulating sources in about half the state. And there's a big attainment problem there for smog, as many of you know. And South Coast adopted a regulation 15 or 20 years ago that strongly limited the VOC content of cleaners used in cold cleaning. And the EPA P2 program funded research on alternatives, and virtually all sources in the South Coast Basin ended up adopting water-based cleaners. The regulation in that case reduced VOC emissions by 18 tons per day. Over the next several years, the rest of the state followed South Coast's lead, and the total reduction in VOC emissions in the state ended up amounting to about 36 tons per day. Now, during the development of the regulation, there was a lot of discussion with other stakeholders, people like hazardous waste people, and particularly POTWs, who were concerned that companies would simply just pour the spent water-based cleaners into the sewer, and they didn't want that to happen. There were also discussions then about how to handle the water waste, and several different agencies were involved in these discussions. And the infrastructure for the alternative equipment, the water-based cleaners, the servicing of the baths, and the spent water waste disposal ended up being standardized throughout California. And it's a model that could be adopted by other states or localities. This slide shows several different models of parts cleaners that can be used with water-based cleaners. Some are made of metal, as you can see, but most are made of plastic. And on this slide, 3 of the 4 systems are plastic. The units are often sink on a drum models, where the drum holds about 30 gallons of a cleaner, and the sink is mounted on top of the drum. Other models are immersion systems, like the green one on the bottom right. It has a removable sink that allows parts to be immersed. You'll want to do this if you have really heavy contamination. You might need it to sit in that water-based cleaner for a while to loosen the contaminants. And these particular water-based cleaners are heated to about 105 degrees F. And they're not heated higher because you want to make it comfortable for people's hands, because the workers are going to put their hands in them. And the cleaners that you use also need to be neutral to slightly alkaline so that they won't hurt workers' hands. And with these systems, there is commonly a pedal that pumps cleaner through an applicator or a brush in the sink area where the parts are cleaned. There are other types of water cleaning systems for this sector that I don't show here. And they would include small spray cabinets and small ultrasonic systems. I showed you a picture of a spray cabinet for vapor degreasing alternatives, and it would just be a smaller system than that. And the ultrasonic systems that would be available are especially useful for cleaning parts that have blind holes and crevices, parts like transmissions, and shops that rebuild transmissions would use systems like that. Now, the next application I'll talk about is paint stripping. Paint stripping is done in a lot of different sectors. In the NEAs of focus here, the types of companies that perform stripping include metal parts manufacturers or assemblers who have coating processes, and they made a mistake and they might need to rework a part. They also include companies making and maintaining aircraft and aircraft parts that are coated. Companies that work on vehicles like auto body shops might use paint strippers. There are companies that refinish and refurbish old cars, sometimes classic cars, and they use paint strippers. Some shops that specialize in painting cars, like Earl Scheib, for instance, they may also use paint strippers. Finally, there are a lot of small shops that do wheel stripping and repainting, and they would use paint strippers. The larger companies or operations in these categories might purchase their stripper in larger quantities from suppliers or distributors, whereas smaller businesses or operations like the auto body shops, for example, they would purchase their stripper from big box stores. The solvent that's most commonly used in paint stripping is methylene chloride. And I already mentioned the toxicity problems that it has. N-methylpyrrolidone, or NMP, to a smaller extent, is also used. Now, it turns out that NMP is a reproductive and developmental toxin. And NMP, like methylene chloride, is on the list of the first 10 priority chemicals that EPA is currently regulating under the Toxic Substances Control Act amendment. Now, a regulation to ban methylene chloride in consumer product paint strippers under the Toxic Substances Control Act was proposed in January of 2017, prior to the last administration taking office. But it was later put on hold, of course, as many of you may know. And public outcry about deaths that had occurred from exposure to methylene chloride forced the administration to ban methylene chloride use in these paint strippers last year. So those products can no longer be purchased at hardware stores or big box stores, or in fact, online for the most part. The environmental community at the same time also made an effort to get suppliers to stop carrying NMP-based strippers. And many companies did commit to stop carrying those products as well. I did a sort of survey after the regulation went into effect and the pledges were made, and I have a report summarizing what I found if anybody would be interested. This slide shows a dip tank containing a methylene chloride stripper in an aerospace facility. Now, the way you would use a dip tank, you would put parts into the dip tank to let them sit for a while so it would loosen the paint so it could be more easily stripped off. And the other picture on this slide, the lower one, shows a large aircraft part awaiting stripping. The stripping alternatives vary depending on the specific sub-application in this category. And companies that have coated a part and need to rework it, they can simply strip the part before the paint cures. This requires timely quality control measures, obviously. And if you catch it before it cures, almost any solvent can be used to remove an uncured solvent-borne coating from a part. For example, acetone could be used for this purpose. And I just want to mention that I like acetone a lot, and acetone is lower in toxicity than nearly all other organic solvents, and it's also not classified as a VOC. Now, in the case of an uncured waterborne coating, you can just use plain water to remove that coating, as long as you, again, catch it before it cures. Now, if the paint does cure in both cases, however, a stronger stripper will have to be used. And if a company does let the paint cure, the alternatives are benzyl alcohol strippers, or in some cases, heated alkaline strippers, which can be used for stripping the types of metals I show on this slide. And just to mention benzyl alcohol, which I'm suggesting, it has been tested for chronic toxicity and it's not a carcinogen. The picture on this slide shows a tank at a company. It's a deep tank, as you see there, in Southern California that manufactures waterborne paints. Instead of simply flushing the tank right away with water after the batch of waterborne coating was made, the paint ended up curing in the tank. A worker entered the tank to strip it with a methylene chloride stripper he purchased from a big box store, and he was overcome because of the high concentration of the methylene in the stripping process. And another worker entered the tank to help him, and he was also overcome. The first worker ended up dying, and the second one was in the hospital for quite a while, but he did survive. And this, in particular, was one of the events that prompted the ban on methylene chloride in consumer product paint strippers. Now, aircraft are increasingly being made of composite material, and you can't use methylene chloride on composite. It crazes it. So new aircraft can't really be stripped with methylene chloride anyway, and new methods have to be used instead. An alternative in the case of aerospace parts is to use a benzyl alcohol stripper again, and some of these are used. For large portions of an aircraft, however, you have to use something different, and you can use a technology called Flashjet. This combines light energy with dry ice blasting, and it's currently used by a few facilities. Media blasting that uses different types of media like wheat starch or plastic can also be used. Lasers for stripping continue to be investigated, particularly by the Department of Defense and their contractors, and they've been used at some aerospace facilities. Hill Air Force Base did have a robotic laser stripping operation, but they took it out. I actually did some testing of a laser stripping method, but that method was never commercialized. One of the best alternative options is to simply not paint the aircraft in the first place. American Airlines has adopted this option. And when American Airlines does their maintenance, they don't have to strip the aircraft. It just has a decal on it and it's bare aluminum clad. Most auto body shops don't use strippers. In many cases, particularly for new cars, the technicians will simply replace the damaged part, like a door or fender, with a new part from the factory. In other cases, in the older cars, for example, the technician will knock out the damaged area, sand the surface, and coat the area after matching the paint. So hand sanding in the auto body industry is a good alternative to using methylene chloride stripper. For aftermarket cars and specialty paint companies, they often strip the whole car. The alternatives are to use benzyl alcohol strippers. They can also sand the whole car, which is quite labor intensive. So if they are larger and can afford it, they can buy a media blasting booth. They have small media blasting booths for this purpose. Now, as I mentioned, wheel stripping is a pretty big business done by a lot of small companies. And some of those companies have adopted benzyl alcohol strippers. This slide shows an auto body technician over on the left-hand side using a sander, a DA sander, to remove the paint from a car door. The other picture shows an aircraft with a window area marked off, as you see there. It's masked off in preparation for a media blasting operation. The next application I'll talk about is auto aerosol cleaning. There are 4 ways aerosol cleaners are used in this application. They include the 4 areas that I've listed on the slide: brake cleaning, engine degreasing, carburetor and fuel injection system cleaning, and general purpose degreasing. The solvents used for many years for these purposes have been the halogenated solvents historically: trichloroethylene, perchloroethylene, methylene chloride, and propylbromide. But other non-halogenated solvents, like petroleum solvents in particular, are used today in blends as well. Now, almost 20 years ago now, the California Air Resources Board, which is responsible for regulating air emissions from consumer product categories, and those consumer product categories actually covered the auto aerosol cleaners, they adopted a ban on the use of TCE perc and methylene chloride, and they also established a low VOC limit of 10% on these products. This meant that N-propylbromide also could not be used either, since it is classified as a VOC. The industry reformulated their products to accommodate this regulation, and they designed several that are specific for California, and they're labeled that way. It'll say CA on the product. Auto repair shops indicate that 90% of the brakes they clean only have dust and fingerprint contaminants, so they're very easy to clean. And the remaining 10% might have some brake fluid or oil on them. Now, shops can use various types of water cleaning equipment to clean brakes in place of the aerosol cleaners, and I'll show you pictures of some of these different types in a minute. And Engine degreasing can also be performed with water or water-based cleaners, and detailers commonly will use wands that flush the engine. Now, most cars today, the newer ones, have fuel injection systems, and cleaners for them are flushed through the system and they're combusted. So they're not emitted, so you don't care about them for smog reasons, and you don't care about them for worker exposure reasons. Carburetor cleaner is generally used to clean throttle body valves and also carburetors on old cars. And aerosols are generally used for that purpose. And aerosols are also commonly used for general purpose degreasing. Auto repair facilities can continue to use aerosols for throttle body valve cleaning and general purpose degreasing. And they can use products that don't contain the halogenated solvents, which are lower in toxicity and they're low VOC. And these would be the California designated products that have been designed to meet the California regulation requirements. These products most often contain acetone. And as I already mentioned, acetone is a good alternative. It's not a VOC and it's lower in toxicity than most organic solvents. The formulations generally also rely on carbon dioxide propellants rather than hydrocarbon propellants, which turn out to be VOCs. The carbon dioxide in these propellants is taken from sources that would otherwise be emitted, so they don't contribute to an increase in the global warming emissions. Now, shops could, of course, also continue to use aerosols in all four applications, and for doing that, they would rely on the California-specific aerosols. Technicians can also buy canister systems and use a lower toxicity cleaner in them for cleaning. They avoid the use of aerosols altogether with that option, and as you may know, aerosols are pretty expensive comparatively speaking, and they also present a disposal problem. Auto repair facilities can also use spray bottles with safer cleaning ingredients like acetone or even a water-based cleaner in place of the aerosol products. The spray bottles, however, they don't deliver a really high pressure stream like the aerosols do, so technicians might not really like that option. Now, this slide shows pictures of 3 different types of brake cleaning system. Now, when you do a brake job in an auto repair shop, technicians will raise the car up generally so they have better access to the brakes. And these systems are on wheels, so you can just roll them under the brakes for cleaning. And each of the systems holds maybe 3 gallons of a water cleaner, and they're used at room temperature. And the basins, I think you can see it in most of these cases, they generally contain a brush. This slide shows a detailer flushing an engine with water. And the bottom picture shows a technician using an alternative low VOC, low toxicity general purpose degreaser that we had specially formulated when we worked on a P2 project. This slide shows a manager at a dealership. We worked with him, and he tested a water-based brake cleaning system. The unit you see here that's red with the sink on top. And he's holding also some aerosols we formulated in the project, which he tested for us as well. And the bottom picture shows a canister system he also tested for us, and it contains a formulation we came up with. This was a dealership we worked with. Now, many other types of companies use aerosols as well, and this is my next application that I'm going to discuss. Numerous industrial companies that manufacture or assemble parts of various kinds, they like the convenience of using aerosol cleaners. And the advantage is that they can clean in hard to reach areas where you can't get other cleaners often. And these aerosol cleaners are often used for touch-up cleaning or more widely for surface preparation. And the solvents that are used in aerosol cleaners would include halogenated solvents like trichloroethylene, and also a wide range of non-halogenated solvents that are generally classified as VOCs, and they often have toxicity problems. There are literally thousands of different operations where aerosol cleaners might be used, and industrially, and they're very diverse. One thing that's challenging in selecting an aerosol cleaner for an application is that you have to weigh the cleaning capability and the evaporation rate. Technicians and people in these companies, they definitely want something that evaporates quickly. And so you have to use something like that, but you also need to inhibit its evaporation rate if it evaporates too quickly. And I've formulated a lot of these cleaners, and I know this is challenging. It can be done more easily if you don't have to worry about VOC limits, which I always did because I was working in Southern California. So one alternative option is to eliminate the aerosols altogether and use spray bottles, which I already mentioned in the auto repair applications. And you could use a cleaner the company selects. Again, this would eliminate the expense and disposal problem with the aerosols. But it may not, once again, as I already mentioned, deliver a high enough pressure spray to be effective. Now in California, the California Air Resources Board has banned TCE, PERC, and methylene chloride in many cleaning applications where aerosols are used. And they've also set low VOC limits. And the California cleaners on the market would represent low VOC products that could be used as safer alternatives. And most of these products, again, are based on acetone. The best alternative would be a blend of acetone and a glycol ether or a hydrocarbon that are low in toxicity. Again, use of aerosols with a carbon dioxide propellant would avoid the use of hydrocarbon propellants, which are VOCs. Now, the next application I'm going to talk about is on this slide. And companies often apply coatings or adhesives in booths with spray equipment. And other companies will use brushes or rollers to apply the products or for touch-up. And even people in the field will use these things for coating. And the different types of application equipment, including the lines that need to be flushed, they will all need to be cleaned. And coatings are also often thinned, particularly if they're being applied with spray equipment. The cleaners and thinners used for these purposes are generally non-halogenated VOC solvents like MEK, lacquer thinner, or toluene. And all of these, of course, have toxicity problems. And some companies will purchase their solvents for cleaning, coating, and adhesive application equipment from suppliers in larger quantities, but others might purchase them from big box stores. Now, this slide just shows some examples of the application equipment. I'm showing two types of spray guns on the top. And one of these, as you see, the one on the left, the silver one, has a large cup which feeds coating to the sprayer. And the pictures on the bottom show a typical brush or a roller that you might use to apply coating. California has set low VOC limits for alternative cleaning and thinning solvents. Cleaning solvents are regulated directly, and thinners are regulated as part of the coatings or adhesives when they're applied. It'll say in the table for the VOC content limit, as applied, and that means after you've added the thinner. Now, if the adhesives or coatings are waterborne, plain water can be used for cleanup of the equipment. Acetone can be used for cleaning a large majority of the solvent-borne coatings and adhesives that are on the market. Plain acetone may not be effective in certain cases, but usually it is. But in certain cases, it might not. So you might want to add small amounts of a VOC solvent to boost the cleaning capability. The top two pictures on this slide, they show different types of spray gun cleaners that are available on the market that you can purchase. And the spray gun in these cases is attached to a flushing apparatus in the device, and solvent is flushed through it. and the solvent is reused repeatedly. The bottom picture shows an auto body shop we worked with on a project, and they were doing a test on a low VOC, low toxicity thinner we formulated for them. Like aerosol cleaning, hand wipe cleaning at industrial companies is diverse. And I'm going to talk about that now, and the alternatives are suitable on a case-by-case basis. Generally, in this case, a solvent is used on a rag or a wipe to wipe down a small or large part for surface preparation or perhaps before repair or maintenance. And the solvents that are most commonly used are VOC solvents like MEK and toluene, although some halogenated solvents might be used for certain purposes as well. This slide shows a picture of a typical red can device. You see these all over the place in certain industrial companies, like companies that make fasteners, for example. And you're going to put the wipe that you're going to use on top of this system in a little tray, and you're going to depress it down with a plunger. And that plunging action gets solvent to be pushed up onto the wipe, and the wipe can then be used to clean the part. The South Coast Air Quality Management District in California, this was 15 or 20 years ago as well, they adopted a regulation that set a low VOC limit on hand wipe solvents, and suppliers have formulations that comply with this regulation. The best alternatives in this case, again, are generally plain acetone or acetone with a small amount of a low toxicity glycol ether or hydrocarbon. The next solvent category I'll talk about is lubricants and metalworking fluids, which are extensively used by companies of all kinds that are involved in the manufacture or assembly of metals. And in this case, companies will cut, stamp, hone, form, and bend metals. And those operations are very aggressive and they stress the metals. The fluids lubricate the metals and reduce the heat and friction between the tool and the workpiece, essentially cooling it so you don't have a lot of smoking or burning in the operation. These fluids can also help to carry away chips that are sometimes generated in the process. Many metalworking fluids are based on petroleum products that are VOCs, and they often contain aromatic components. These would be materials like benzene, toluene, and xylene, and they're all toxic. The fluids also are often thinned with things like kerosene, and that, of course, is toxic too. If you like, you can think of metalworking fluids as heavy solvents that evaporate very, very slowly. Some of the fluids, notably the so-called vanishing oils, actually evaporate quite quickly, and thus the term vanishing. This slide shows a number of different types of operations which rely on metalworking fluids. The top left picture is a stamping machine at a nameplate manufacturer. The picture to its right shows a honing machine at an aerospace subcontractor. The bottom left picture is a picture of a cutting machine at a welding equipment manufacturer. And the last picture on the right bottom shows a tube bending machine at a ducting manufacturer. We worked with a number of companies to find alternatives in a P2 project. And these are pictures of the companies we worked with, some of the companies we worked with. Now, in Southern California, the South Coast Air District, I feel like I keep repeating that, but it's necessary for me to do so because it's true. The South Coast Air Quality Management District adopted a regulation based on some of the results in our project. And it established low VOC limits for lubricants and metalworking fluids. And the alternatives that can be used in this sector include water-based and vegetable-based products. The water-based products can be thinned with water. And in some of the most stressful operations, companies have historically and still continue to use chlorinated paraffins as lubricants, and these are recognized internationally to be toxic. Water-based and vegetable-based lubricants can be used as alternatives for these as well. There are thousands of different coatings and adhesive products on the market today, and they're used by numerous manufacturers and assemblers. The larger companies in this category, or the people that have larger operations, would purchase their products again from suppliers or distributors in larger quantities. But small shops or operations could purchase their coatings or adhesives from big box stores. And some of the coatings and adhesives are also in aerosol forms that they would purchase at these big box stores. Now, many of the coatings and adhesives are solvent-borne, and they generally rely on non-halogenated solvents, but some adhesives still use halogenated solvents. Coatings in particular can be especially complex mixtures of ingredients, so they're pretty difficult to formulate. And the solvents that are used in these products, they act as carriers for the solids in the formulations. And in many of the cases, the evaporation of the solvent leads to curing of the product. Alternative products, again, will be suitable on a case-by-case basis. I guess I'm trying to make that point, that you really need to look at every operation individually. And high solids coatings are things like powder coating, roll coating, dip, or flow coating. And these can be used in certain operations. For adhesives, the high solids alternatives would be epoxies or hot melts. Another option in the sector is waterborne products. The auto body industry in Southern California is converted to waterborne base coats because of a regulation passed some years ago by the South Coast Air District. And there are higher airflow booths that have been designed to accommodate the drying requirements, and I'll show you pictures of those in a minute. Companies and their suppliers often have to figure out how to change things to accommodate a new process, and it can be really complicated. And a good example in this particular case that I'm talking about, the waterborne base coats, the suppliers develop different drying methods because the waterborne products don't dry as fast as the solvent-borne products. And I just want to bring up another example of an accommodation that had to be made. It would be in the furniture industry adhesives that are used by foam fabrication companies. And instead of using the methylene chloride or N-propyl bromide based adhesives, which they historically used, and those dried very quickly because the solvent evaporated quickly, and the adhesive people, they had to figure out a new way to stage things when they adopted water-based adhesives. With the solvent adhesives, they would spray 2 pieces of foam and they'd clap them together instantly because they had good enough adhesion from the evaporation of the solvent to bond instantly. And at first, they thought there would be really significant delays because the workers would have to stand around and wait for some drying to occur to get good adhesion before they could bond the 2 pieces together. Instead, they figured out a way around it, and they could keep spraying several different pieces of adhesive down a line at a time and go back to the ones they started with and clap them together, because by then enough of the water would have evaporated. And it just took figuring out what kind of different staging they needed to use. Low VOC content products are also alternatives in these cases, and they're often based on acetone, once again. Finally, UV curable coatings and other light curable coatings are also an option. That might be a little too expensive for some companies, however. That isn't a cheap alternative. Now, this slide shows pictures at 2 auto body shops we work with in California where they're applying waterborne base coats. And this slide, as I promised, shows some pictures of drying systems designed for auto body shops using the waterborne base coats. And the top picture on the left shows a small booth with 3 fans in it. It's a 3-fan drying system that they came up with. And the bottom picture here shows another approach to drying, and it's called the June Air system. The one over on the right-hand side, the picture, shows a handheld drying aid that these companies can purchase to enhance the drying. Now, this presentation is focused on the solvent applications that are covered by the current NEAs, as I said. And accordingly, it leaves out many additional applications where solvents are used. And I just want to mention what some of those are. Solvents are used to clean electronics and microelectronic components. They're used in a range of paint stripping applications that I didn't talk about, like wood refinishing, which is largely furniture stripping. They're also used in bathtub refinishing, where you're stripping acrylic, porcelain, or fiberglass materials. They're used in stripping boats that are made of fiberglass. They're used by contractors in the field, where they're stripping kitchens and offices, the cabinets in them. And they're also used in consumer product strippers, as I already mentioned, sold at hardware and big box stores. Most of the dry cleaners in the country use solvents, and solvents are also used in the chemicals they use to spot garments. Solvents are also used in graffiti removers, and this is a huge issue for cities and counties. They pay millions of dollars every year to mitigate the graffiti that are in all the cities. And solvents are used in a range of other coating types as carrier materials, things like wood coatings and in some architectural coatings. Some furniture adhesives used for bonding porous substrates like foam and fabric, they also still rely on solvents. Solvents are used during welding or laser cutting operations in anti-spatter formulations. They're used by screen and lithographic printers for cleaning equipment. They're also used to clean tanks and process hoses by the pharmaceutical industry. Release agents for concrete and asphalt operations might also rely on solvents. Solvents are used in mold cleaning, floor wax strippers, and for biocidal control in the biotechnology industry. If people are interested, we could focus some webinars on these applications in the future. Now, there are definitely other solvent applications that I don't list at all. Things like mask and operations at aerospace facilities or adhesive removal. So that's all the applications I'm going to talk about today, and I just wanted to highlight some issues that arise when companies adopt alternatives. These largely apply for P2 providers, but if there are companies listening, they can also take note of them as well. It's obvious by now that solvent applications are really diverse and that alternatives obviously have to be considered and selected for each case. The P2 providers need to have a good knowledge of the sector and the range of alternatives, both good and bad, that a company might be able to adopt. And developing this kind of expertise can take really a lot of time and energy. However, there isn't a shortcut, and you just have to work with a lot of different companies to develop that expertise. And another issue is that companies generally trust their vendors, and some vendors will guide them properly and some won't. If you're a P2 provider helping a company, you have to know enough to tell the company when a supplier is moving the company in the wrong direction. Now, they might not believe what you're saying, and they might believe the vendor instead, but you just have to give it a shot, I think. Another issue is that you have to work with companies in a practical and common sense way. You need to know what might be appropriate and what might not in a given situation. I always make a big effort to find a low-cost solution, and nobody wants to pay more than they have to make a conversion. And for example, you can't assume that a really small company that's assembling metal parts is going to use the Flashjet technology for stripping paint. The next issue I'll mention is that regulations are especially good at spurring innovation, and almost all of the innovation in P2 over the last 3 decades has come about because regulations have forced technology. The South Coast Air District and California Air Resources Board in California in particular have been responsible for a lot of this innovation. The South Coast ended up banning TCE perc and methylene chloride in open top vapor degreasing 2 decades ago, really a long time ago. And Minnesota and New York have recently adopted regulations banning TCE. When companies adopt alternatives, a major issue, as most of you know, is regrettable substitutes. In California, they've made some mistakes in the regulations they've adopted over the years in not anticipating future problems. In the 1980s and 1990s, the South Coast Air District encouraged companies to use 1,1,1-trichloroethane or TCA and CFC 113, a chlorofluorocarbon, for vapor degreasing because they weren't classified as VOCs. And the companies in Southern California, many of them converted from TCE, which was a VOC, to TCA or CFC 113 in a few cases. Now, both those chemicals, however, contributed to stratospheric ozone depletion, and production of them was banned worldwide in 1996 under the Montreal Protocol. So the companies in Southern California were angry at the South Coast Air District for pushing them into a solvent that was banned. The South Coast Air District also led the auto body industry to use perachlorobenzotrifluoride, or PCBTF, which is not a VOC in coatings and in certain cases in cleanup solvents. Now, recent results have indicated that PCBTF is classified as a carcinogen. Tert-butyl acetate is another example. The South Coast Air District encouraged its use in industrial maintenance coatings, a type of architectural coating, because it isn't a VOC, and it also turns out to be a carcinogen. The South Coast Air District now has to go back and change several of their coating regulations so formulators can reformulate away from PCBTF and tert-butyl acetate. In the Pacific Northwest, where I am now, the air agencies encouraged companies to stop using TCE and to adopt N-propyl bromide instead. Some P2 providers in other states, like Massachusetts, for example, also encouraged this conversion. N-propyl bromide is just as toxic as TCE and is definitely a regrettable substitute. Some P2 providers have also encouraged companies to convert to global warming solvents. And there are many companies that use them, and if they're regulated in the future, it'll be a problem. Some vendors will tell companies to use products they carry so they won't lose the company's business. If they're supplying a toxic solvent, they likely sell other solvents and not water-based cleaners. In vapor degreasing, for example, some vendors are recommending that companies use 1,2-trans-dichloroethylene or PCBTF in their open-top vapor degreasers. Both of these chemicals have flash points, so it's very dangerous to do this. As I already mentioned, you could set the solvent on fire or have it explode. In addition, PCBTF is a carcinogen, and 1,2-trans-dichloroethylene has not been tested for chronic toxicity, but it is structurally similar to TCE perc and vinyl chloride, and all three of those chemicals are carcinogens. Vendors have also converted companies to global warming solvents, generally in conjunction with 1,2-trans-dichloroethylene. So over the years, we've learned a lot from the mistakes we've made in encouraging the use of regrettable substitutes. One major thing we've learned is that no chemical or group of chemicals is essential. As you know, we have to weigh the damage something might do against its benefits. And we might argue initially that we can't get along without something, but it isn't true, and there are really good examples of this. Production of ozone-depleting substances was banned, as I mentioned, and we were able to find alternatives. They were used in very high-value applications, like refrigeration and air conditioning, foam blowing, and various solvent applications. And a really good illustration of this arises in the ozone-depleting substance realm, and it's the example of the chlorofluorocarbon propellants. In 1979, when they were banned, industry argued that the alternatives, which were the hydrocarbon propellants, were flammable and that plants packaging aerosols would end up blowing up, that it would be a real danger. That never happened, and everything was converted over to hydrocarbon propellants. Some 30 years later, when California set limits on VOC emissions from aerosol applications and hydrocarbon propellants were affected because they're VOCs, the same industries ironically argued that the hydrocarbon propellants were essential. Obviously, it was different people and 30 years had passed, but that was a very interesting development. Now, most companies now are no longer using hydrocarbon propellants in their aerosol industrial products. Asbestos was banned in most applications and safer alternatives were implemented. We're now phasing out global warming chemicals, and we have already and will find alternatives. In California, the South Coast Air District and Air Resources Board enacted many regulations that have eliminated certain chemicals in specific applications, and viable alternatives have been found. Again, we've learned a lot over the last several decades, and we know how to move to safer alternatives, notwithstanding some diversions to regrettable substitutes. Just to conclude then, users in many applications have switched from one solvent to another as the solvent they're using is increasingly regulated. Some of the examples I gave show this. In vapor degreasing in particular, companies are still moving to regrettable substitutes today, and they'll eventually just have to convert again. This is a really costly and time-consuming way of doing it, and it really is better if companies, and if there are P2 providers helping them, find a permanent solution once and for all. It gets you off the hook of the shell game. And it's notable that use of many of the safer alternatives is actually lower cost in lots of cases than use of the chemicals of concern. And we would get a chance to talk about some of those options and their costs if we decide to focus in on some of the applications discussed here in future webinars. So that's all I have today. Thank you for your attention. And I'm showing my contact information. That's my phone number and my email address. And I would encourage you to call me or email me, and you can tell me about your operation and I'll point you in the right direction for alternatives. And I also show on this slide the website of the Institute for Research and Technical Assistance. That nonprofit that I worked at for 30 years, it's been abolished now, but the website still exists. And it has a lot of reports on it that focus in on some of the applications that I did discuss today and some that I didn't. And now I'll be more than happy to answer questions or take any comments you might have.
Thank you so much, Katie. And this is Jean again, and we do have a few questions, and I encourage everyone, if you have a question, I'm going to start with the ones we have, and then you can ask your question in the question box, which is over on the GoToWebinar little panel thing that you should have along with this presentation. Katie, thank you so much. That was a great presentation. It shows the depth of your knowledge and the history that you've had in this industry, and we just really appreciate you sharing with us. One question was, does California have a list of prohibited chemicals for regulated entities to refer to?
And the answer would be no, unfortunately. The South Coast Air Quality Management District often has regulations that are more stringent than the other air districts in the state. And you can go to their website and you can ask for all their regulations, and depending on what you want to know, you can look at the regulation that would affect that operation, and you can see what the limits are. And the California Air Resources Board also has a website, and they regulate, as I mentioned, consumer product applications. And you can just look on their website and click on the consumer product. I think it's called the General Consumer Product Regulation, and you can see the limits in the various applications that the Air Resources Board regulates. And keep in mind that the Air Resources Board does not regulate stationary sources, whereas the South Coast does. So those are operations that South Coast regulates that are done at individual facilities, but the Air Resources Board does regulate aerosol categories, and it's throughout California that those standards are effective, whereas South Coast is just in the South Coast Basin.
Okay.
So I hope that answers it. I mean, I'm sorry, it's complicated.
Yeah, that's all right. Thank you for giving us the right answer.
And if people want to call me about something in specific, in particular, I can point them in the right direction.
Okay, here's another question. Could you please speak more about how innovation relates to regulations and how REACH or TSCA can assist?
Yes, sure. I mean, when I worked with facilities in Southern California, it was always pretty easy to get them to consider using an alternative because they knew there was already a large regulatory regime and that regulations might be coming in the future. So they were open because of the fact that regulations were there and would be there to converting. But what people used to tell me was, I would ask them what would provide an incentive for them to convert, and they would say, make it a regulation, and then we will need to comply. And they actually were requesting that I do that. And I'm now in the Pacific Northwest, and I work with companies, in other parts of the country, and there's very little incentive for them to convert to alternatives, I find. I mean, you can generally get early adopters, as they're called, I guess, 2 or 3 of the companies to convert, but you can get 1,000 to convert if you make it a regulation. So I think that summarizes an answer. I mean, and TSCA is developing regulations, and I hope that will provide more of an incentive for companies to convert away from the solvents that are covered there. And there are 5 that I talked about commonly in these solvent applications that may be either banned or restricted heavily in the future. And then REACH, yes, REACH is a good incentive for companies as well. I'm working with one company who has to comply with REACH all the time. And for example, REACH regulates in water-based products, if you're using an endocrine disrupting surfactant, REACH regulates that today, but we don't have regulations in the United States on endocrine disruptors yet. So that would go beyond what is done in this country.
Okay, thanks, Katie. Couple more. For coating or adhesive applications, you showed use of spray guns. For coatings with chemicals posing a dermal risk, is it realistic to think that coating application could be automated, example, without spray guns?
Yes, I suppose so. I mean, you could always put more automation somewhere. You could have a robotic operation, for example, but it's going to be very expensive to do that, of course.
Okay. Here's another question. What are your thoughts on emerging, quote, designer solvents, unquote?
Well, I'm not sure what is meant by that, but there are several global warming solvents that are sold today, the hydrofluorocarbons and the hydrofluoroethers. And they're generally in vapor degreasing combined with 1,2-trans dichloroethylene, and I already mentioned that it is structurally similar to carcinogens. So it's also on the second set of 20 chemicals that TSCA may regulate. And so it might be regulated in the future. And the HFCs are going to be phased out. And the HFEs also contribute to global warming. So eventually they could be gone as well. Now, those are certain designer solvents. Now, the solvents that they've designed to replace those, there is a hydrofluoroolefin solvent on the market right now, which doesn't contribute to climate change. A toxicologist in California, some of you may have known her. Her name was Dr. Julia Quint. She evaluated the toxicity of the hydrofluoroolefin that's used as a solvent, and she thought it was cardiotoxic. So again, it's adoption of things that might be restricted in the future. In addition, I'll just say that the HFC and HFE blends with 1,2-trans are extremely expensive. And so you have to use them in an airless, airtight system, or the losses would be too expensive to replace. So they're most commonly used in equipment that costs between $400,000 and $1 million. And the HFO is used in open top vapor degreasing, but it's expensive, and it also, the equipment for use with it is expensive.
Okay.
So I think that's the designer chemicals you meant. Whoever asked that question.
We'll let that person respond if you have more to ask about that. Here's a different question. There are some companies that are producing zero VOC or low VOC materials that do not use common VOC exempt solvents. These formulations may be proprietary or not readily shared to the public. How do you look for new alternative solvents? I'm thinking that because once PCBTF or TBAC is regulated in California, companies will be looking for other alternatives to reformulate their products.
Most of the industry doesn't like PCBTF anyway, and they're going to be glad it goes away because it is very expensive relative to other things. So other alternative ways of doing things would be what I discussed. Since PCBTF is used in coatings primarily, only really in California where they have VOC regulations is it used. And people will have to convert either when the South Coast revises their regulation, either to other low VOC products. And I mentioned what some of those are, the high solids or the other materials that might be based on acetone that would be available. And PCBTF, as I mentioned, it's also used for cleanup in cold cleaning units. And you can, of course, use water-based cleaners to do that instead. So there's no need to use it that way at all. And methyl acetate, I don't know that there is an exact alternative for, but the only place it's really used in coatings is in Southern California also, where they have VOC limits, because it's more expensive as well than other alternatives that are VOC solvents in other parts of the country. So people will just have to convert in Southern California once the South Coast Air District removes that option in the coating rule for architectural coatings, certain types.
Okay, and you mentioned acetone just then, Katie, and there was a question. You did talk about acetone a lot, and you like it. You mentioned that you like it, but the question is, what is the trade-off with using acetone?
Okay, the big issue with acetone is its low flash point. So, and that is an issue. So you don't want to use acetone except in applications where it can be used in smaller quantities, things like hand wipe and aerosol applications. Now, you would not use acetone, and it would be very dangerous to do so in a big vat for cleaning. That would be very dangerous. Here's the trade-off that you're faced with, okay? And I formulated alternative products, cleaners in particular. So it's very challenging. You need something that evaporates quickly and that is reasonable cost. And for most of these applications. So other exempt chemicals, in other words, chemicals that aren't classified as VOCs, I can name you some of those categories, and they include global warming solvents, ozone depleting solvents, volatile methylsiloxanes, which are silicones materials, and the D4, one of them that's used in consumer products is, I believe, a reproductive toxin, and D5, the one that's a solvent, is a carcinogen. It's also used in the dry cleaning industry. It's called, I can't remember what it's called for some reason. Anyway, moving on, the other exempt chemicals would be things like PCBTF, which is a carcinogen, terpbutyl acetate, which is a carcinogen. And then there is one that isn't that much of a problem, which would be methyl acetate. And unfortunately, methyl acetate has a flash point that's virtually the same as acetone, and it also has properties that are very similar. And it turns out to be slightly more acutely toxic than acetone, and it's a lot more expensive. So there isn't a whole lot of room to figure out what other type of solvent to use. And that's why I like acetone, because given the trade-offs in using all these other things. Oh, and I should mention that the global warming solvents are very expensive, and they would never be used, for example, in auto aerosol cleaners. And most companies would never purchase them in aerosols in the industrial arena either. And the ozone depleting solvents are, of course, gone and banned. So you can't use them. So there just isn't a whole lot of room for you to move to other exempt solvents because there just aren't that many.
There's been a comment that D5 sold under the name Green Earth. EU.
Yes, thank you. I'm sorry. For some reason, I couldn't remember that.
And EU ECHA has identified restrictions for D4, D5, and D6.
That's right.
Okay.
I wish D5 were not being allowed to be used in dry cleaning anymore.
Thank you, folks, for being on this call today, for helping with your fine questions. Katie, thank you for your excellent presentation. And we would ask everyone to please complete the survey that should appear as we close this webinar. Thank you all. Have a wonderful day.